This lesson, we're going to talk about solving linear equations. And I will show you a few of different types of linear equation solving in example 1. So this first one, we have x minus 16 equals to 7. So solving means that you wanted to isolate the variable and move all other numbers to the other side. So your solution is going to be always x is equals to something, right? It means you need to get rid of negative 16, and you get rid of negative 16 by adding 16. It means you need to do exactly same thing on the other side, where your x will be equals to 7 plus 16, 23, right? The next one, you have 6x minus 8 equals to 7x. So you have more than 2 variable. So you have one x here, the other x there, and you wanted to make x equals to something, and this something have to be only number. It means you wanted to combine these two to make it one variable x, right? So put the number with the variable together. So what I will do here is subtracting 6x on both sides to get rid of this 6x, where I will put all the x together. This gives you 7 minus 6, so it will be just 1x, right? And what I have remaining on the left side will be negative 8. So this is basically saying x is equals to negative 8. Let's look at the next one. I'm solving for p, unknown variable here, and look like I have one here and one there, and I wanted to combine. So I wanted to combine number with the variable together, number without the variable on the other side. So I will do maybe adding 7x to put number with the variable on the left side, and I will do subtracting 8. So I will put number without the variable on the right side. So then I will have 1p equals negative 3. So p is equals to negative 3. Any of this solving equation, you should be able to check your solutions. For example, this one right here, if we replace 23 into the variable, the given equation will be always, given this equal sign, should be always true. That's how we know that's going to be our solutions, right? Same thing on this one. So if you replace negative 3, both sides should be always equals to, right? And if this is equals to, we are sure that your p have to be negative 3. Let's try the next one. This one, in order to get rid of multiplications, so trying to isolate x, you need to get rid of 5 by dividing by 5, right? So it makes it 5 over 5, which is 1, right? So it means you need to divide by the other side by 5. So your x is going to be 5 goes into 60, 12 times. And we know if we wanted to check this one, it will be 5 times 12 equals to 60, which we know that's true. What about example E? If we have 3 over, 3 over 4w equals to 6, then in order to get rid of 3 over 4, what you need to do is you need to multiply by reciprocal to make it 1w, right? it means you're going to multiply the other side by the reciprocal. Same thing, right? So this cancel out. This become 1W. And you know that 3 goes into 6 twice. So this is same as 2 times 4, which is going to be 8. And if we check this, this should be equals to each other, right? When you replace W with 8, 4 goes into 8, 2 times 3 is 6, right? So solving equations, any types of equation, you can always check your solutions. Let's try this one. So first thing I wanted to do is get rid of addition, subtraction first. So I will subtract 5 both sides, which will give me negative 6x equals to 12. And then in order to get rid of this multiplications, you're going to divide by negative 6 both sides, which makes it 1. So 1x is equals to, you have 1 negative, so solution is negative. 6 goes into 12 2 times. So x should be negative 2. Okay, so these problems are getting bigger. When you have a parenthesis, you need to get rid of that parenthesis so you can combine the like term. So let's distribute this 4, right? Distribute. Then you will end up getting 4k minus 12 minus k equals to k minus 6. The next thing I wanted to do is combining like terms so that there will be less value that I'm going to move around to other side of equations. So look like this 2 is the like term from the left side. So when I combine that, it will give you 3k minus 12. The other side is already simplest form. And then let's see which side I wanted to move. So if I move number with the variable to the left side, it will make it positive because 3k was bigger, right? It means I'm going to move the number to the right side. So then this will give you 2k equal, that will be 6, positive 6. And then the last thing we need to do is dividing. 2 over 2 makes it 1. So k is equals to 3. So again, long as you don't make any mistake in between, that should satisfy these equations right here, right? Okay, next 2 problems. So this one, I see 2 parentheses, so let's distribute. Negative 3 times negative 4 will make positive 12 plus 5 and 10. You're distributing negative sign, so that will become negative x and negative 1. So make sure you're distributing this negative twice. And that's very common mistake, not distributing the sign onto the second term. But don't forget, that's what you need to do, right? So then, let me erase this negative. Hold on. I'm trying to write negative 3x. Oh, that was what the black. Now, combine the like terms. So these 2 look like the like term, and these 2 look like the like terms. That gives you positive 17, negative x plus 9. Look like you wanted to bring all the number with the variable onto the left side by adding x and subtracting 17 to bring the number itself to the right side. Then I get negative 2x on the left side. Right side will be positive 9, negative 17, so it will be negative 8. Dividing both sides by negative 2, your x should be positive 4. Last one. What about if it's a fractions? So I'm going to write this fraction again. And I'm going to show you what I will do if it's a fractions. Fractions, remember all other problem when we're looking at this, we had no problems doing it. Linear is usually one of the easiest equations to solve. But many people have problem with the fractions. So what about if we can get rid of the denominator to make it just regular linear equation solving? And we can do that. We have denominator 5, 2, and 3. So if we end up finding least common denominator of these three numbers and multiply it throughout the equations, then we should end up getting rid of denominator, which means no more fractions, right? So least common denominator of 5, 2, and 3 is going to be 30. So we're going to multiply this by 30 over 1, this by 30 over 1. Because you have two terms, distribute, you end up multiplying 30 over 1 to all the terms. And you get 6 remaining, denominator is 1. 15 remains, denominator is 1. 10, denominator is 1. So no more denominator. So if I write down what I have so far is 6 times 3x minus 15 times x minus 3. And then 10 times x plus 2 is what I have remains. So this is no different than this problem now, right? So what do we do? Distribute to open the parenthesis. So that will be 18x minus 15x plus 45, because negative 15 times negative 3. Then this becomes 10x plus 20. Combine the like term, you get 3x plus 45 equal 10x plus 20. You're going to, I wanted to make it positive so then I can subtract to put number with the variable on the right side. It means I need to subtract 20, so I will have number without the variable on the left side this time. It doesn't really matter where you have x, right? Long as you can isolate them by itself. Now divide by 7. You get x is equals to 25 over 7 as the solutions.